Hello my friend, welcome to my channel. So today I am going to work on a problem related to hypothesis testing. So here we are going to look at the population mean when sigma is unknown. The population standard deviation is unknown. So let's look at this example. An educator claims that the average salary of substitute teachers in school district is less than $60 per day. A random sample of 8 school districts is selected and found that average daily salary is $58.88 and standard deviation is $5.08. Is there enough evidence to support the educator's claim at alpha equals 0.10? So let's identify the null hypothesis and the alternative hypothesis of this test. So look at the claim here. An educator claims that the average salary of substitute teachers in school district is less than $60 per day. So the claim is the alternative hypothesis. The mean should be less than $60. And then null hypothesis is equal $60. So these are the two hypotheses in this test. And now let's look at the information here. A random sample of 8. So the sample size n equals 8 is selected and found that the average daily salary, so the sample mean equals 58.88. And standard deviation is 5.08. As you can see, this standard deviation is from the sample. Therefore, we use the notation for sample standard deviation S equals 5.08. As you can see, the population standard deviation sigma is unknown. So we have no information here about this number. So if you don't know this number, then we have to use t-test. So we are going to use t-scores. Okay, so let's find the test statistic of this hypothesis testing. So the formula for this one, T naught equals x bar minus mu over, now instead of sigma, now we have S over square root n. So x bar is 58.88 minus mu is the hypothesized value, which is 60 divided by simple S is 5.08 divided by sample size is 8, square root 8. So the value of this T naught is negative 0.624. Now we have the test statistic value. So in this problem, I am going to use critical value method and the p-value method. So let's look at the critical value method. So we have to look at alpha value here. Alpha is 0.10. As you can see, this is less than $60. So we are looking at the left tail test. Left tail test. So we have one tail, right? So when you have one tail test, then now this distribution is t distribution. We are looking at the left tail. So this area under the curve here at the left tail is 0.10. So we are going to find this critical value here, the cutoff value over here, right? So now we are going to use the t-table. To use the t-table, we need degrees of freedom. Degrees of freedom is sample size minus 1. Here sample size is 8 minus 1, which is 7. So the degrees of freedom is 7. So in the t-table, you look degrees of freedom 7. So here the first column is degrees of freedom. So you go to 7 here because the degrees of freedom in this problem is 7. And since we are using one tail test, so you look at over here one tail 0.10. So look at 0.10 under one tailed. So then you will see a number over here 1.415. So this is the t value from the table, right? So as this table represents only the positive values, since we are in the left tail, so that means we need negative t values. Since this is the positive t value, so our required critical value here is negative 1.415. So this is the critical value in this problem. Now let's find the p-value of this problem. P-value is the probability, the test statistics less than the t-value less than t naught. So we are looking at extreme values and we need to find that probability of extreme values here when the null hypothesis is true. To find this probability, we need to do this. So since this is probability t less than negative 0.624. So this t naught is the test statistic value. So since the t table has positive values, we just consider the positive value of this number 0.624. So first you need to look at the degrees of freedom 7 and then you need to find two t values that 0.624 falls between. So we consider the positive value here. So you need to find two t values that 0.624 falls between. Then you will see those two numbers are this number and 0.711. So these are the two values here. And then you need to look at under one tail, look at the values corresponds to these two numbers. Then you will see those alpha values, the area values under one tail is 0.50 and 0.25. So that means your p-value between 0.50 and 0.25. So here we cannot find the exact p-value, but we can have a range for the p-value like this. So p-value is between 0.25 and 0.50. So you can find your p-value like this. So p-value between these two numbers. And to make a decision, we compare our alpha value with this p-value, right? So let's find the decision of this testing, right? First, let's look at the critical value. So the critical value is this one, right? So compare this critical value with your test statistic. So we have the critical region. So this number is negative 1.415. So this is your critical region. This is the critical region. So this is non-critical region. So your test statistic value, if you compare with the critical value, that number falls over here, right? So that means we fail to reject the null. Because your test statistic value falls in non-critical region. The statistic value is greater than your critical value. So that's why we fail to reject the null according to the critical value method. Now let's go to the p-value method. So we found that p-value is between 0.25 and 0.50. So alpha value is 0.10. So as you can see, 0.10 is over here, right? It's less than 0.25. So your p-value is greater than your alpha, right? Because alpha is less than, it's over here. P-values are in between 0.25 and 0.5. Since p-value is greater than alpha in this testing, so we fail to reject the null. So then how do you write your conclusion? Since we fail to reject the null, there is not enough evidence to support the claim. Claim, what is the claim? Claim that the educator's claim is the average salary is less than $60 per day. So we fail to reject the null. So therefore, there is not enough evidence to support the claim. Claim is under null hypothesis. So this is the conclusion of this problem. So I hope you understand this question. If you have any questions or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.